Dear friends, today's topic is polar form of a complex number. Let the complex number z is equal to x plus iy be represented by the point p x y in the complex plane. This is the complex plane or the Argand plane. Let angle XOP is equal to theta and modulus of OP is equal to R, which is greater than 0. Then P R comma theta, that is this point P R comma theta, are called the polar coordinates of the point P. We call the origin as pole. Now we shall discuss about the polar representation of a complex number. Now we again draw the Argand plane, origin O, y-axis, let P be the point whose coordinate is a comma b. We write this point in complex form, say z is equal to a plus ib, where a comma b belongs to R. Now we join the point O to P. We draw another perpendicular from the P on the x-axis. So this is PM. Now triangle PMO is a right angle triangle where OM is equal to small a units and MP is equal to small b units and OP is equal to R. So using trigonometry, rules of trigonometry, we find that B divided by R is equal to sin theta. Therefore, B is equal to R sin theta, number 1, and A divided by R, that is A divided by R, base divided by hypotenuse, is equal to cos theta. Therefore, A is equal to R cos theta. This is number 2. Now, squaring and adding, we find b square plus a square is equal to r square sin square theta plus r square cos square theta, or a square plus b square is equal to r square into 1, because if you take r square common, you will find in bracket sin square theta plus cos square theta, which is equal to 1. Therefore, R is equal to root over of a square plus b square. And again from this one, z is equal to a plus ib. Therefore, modulus of z is equal to root over of a square plus b square. Now see this one, modulus z is equal to root over a square plus b square, and you are getting R is equal to root over a square plus b square. Therefore, R is equal to modulus z. Now, if we divide equation 1 by 2, we find that R sin theta divided by R cos theta is equal to B by A. R is cancelled. Tan theta is equal to B by A. Therefore, theta is equal to tan inverse B by A. This theta lies between minus pi to plus pi. Now we sum up this concept. The z is equal to a plus ib. We find that a is equal to r cos theta and b is equal to r sin theta. So z, that means a plus ib, can be written as r cos theta plus ir sin theta. This form is called the polar form or trigonometric form or modulus amplitude form of z. Here r is equal to root over of a square plus b square is equal to modular z is called the mod z, and theta is called the argument or amplitude of z. Now we shall discuss about a complex number I, and which can be represented in polar form. Now, do you share with me that I is a complex number? Obviously I is a complex number, because this I can be written as 0 plus I into 1, which is of the form a plus ib, where 0 and 1 both are real numbers. Let z is equal to r cos theta plus ir sin theta. Now compare this one and that one. We find r cos theta is equal to 0 and r sin theta is equal to 1. So write it. R cos theta is equal to 0, r sin theta is equal to 1. Now squaring and adding, we find r square into cos square theta plus sin square theta is equal to 0 plus 1 square, or r square is equal to 1, because sin square theta plus cos square theta is equal to 1, or r is equal to 1. Don't put r is equal to plus minus 1, because any distance is always positive. The distance is always positive. So we can put r is equal to minus 1, and modular z is equal to always 1, because this is positive number. We can't put r is equal to minus 1. Now dividing 2 by 1, we find r sin theta divided by r cos theta is equal to 1 divided by 0, or tan theta is equal to undefined. Therefore, theta is equal to pi by 2 radian. Now what was our complex number? This was z is equal to I. Z is equal to I, and I was taken as r cos theta plus ir sin theta. Write it again, r cos theta plus ir sin theta. So now replace this r by 1 into cos theta. Theta is equal to pi by 2 plus I into 1 sin pi by 2. Therefore, z means I is equal to cos pi by 2 plus I sin pi by 2, which is the required polar form. Thank you. Have a nice day.